Welcome, everyone, and thank you for attending today's webinar on accelerating software compliance with AI. My name is Ricardo Camacho, and I'm the Director of Safety and Security Compliance. Today's topic is going to focus on integrating AI into the static analysis workflow. Currently, our AI solutions can prioritize static analysis violations, perform triage by identifying and ranking the most critical issues. But with generative AI, we can further enhance the static analysis process by recommending how to remediate identified violations. So we have some very exciting information to share with you. Also, this presentation is part of a series of AI webinars that have been delivered. The last one was on the pros and cons on generative AI testing. One other one was on how AI is a game changer for software testing. So I highly recommend visiting our website, where in the resources webpage, you will find these webinars and actually a library of interesting content. Our presenters today will be Igor Kivilenko, Chief Product Officer. He has been with Parasoft for many years. He's a visionary, very innovative, and leads our development and product management in strategy and execution. So has been working on incorporating lots of automated software testing capabilities, including, of course, AI and machine learning. We also have Nathan Jakubiak, Senior Director of Development, another brilliant mind, holds several patents, leads multiple development teams here at Parasoft, and has been adding these intriguing AI capabilities into our tooling. I have to say, both of these gentlemen are responsible for providing immense value to our customers and differentiating us from others. Now, a couple of notes before we continue. We are having a Q&A session at the end of the slide presentation, but you can start submitting your questions at any time. Also, the presentation is being recorded, and you will be receiving an email with a link to the video so you can rewatch or share with your team. Okay, I'm going to start by putting static analysis in context, and then I'm going to hand it over to Igor and Nathan. Now, static analysis is the evaluation of the source code without having to execute it in order to identify various types of defects. Coding defects that pose safety risks, such as memory leaks, threading problems, division by zero, and many other coding defects that can also crash the application or have it function in a way that it's unsafe. And in safety critical systems, these failures can actually cause death or harm to people. Static analysis can also identify security vulnerabilities, such as buffer overflows, the use of libraries with known security vulnerabilities, weak cryptography, and it's a long word anyways, framework-specific command injection errors, and can also provide metrics on the code, such as maintainability, portability, complexity, and actually other types. Now, static analysis can also ensure that software engineers adhere to the organization's coding rules. I remember many decades ago having code walkthroughs with my peers as a way to ensure compliance to the organization's coding rules, and also in identifying coding issues. Today, of course, this can be done automatically. For example, Parasoft's static analysis engine performs pattern-based static analysis. It identifies known coding patterns or coding constructs that can cause unpredictable behavior. Data and control flow analysis is another static analysis technique that performs a simulation of execution, taking into consideration the data and the control flow to identify paths of execution that could trigger runtime defects. Defects like the use of uninitialized memory, the use of null pointers, division by zero, memory leaks. It exposes bugs that evade pattern-based static analysis, and can even expose bugs that evades unit testing. If you're not performing static analysis, you should be. What it also does is shifts left testing so you can find defects earlier and fix them when they are actually the cheapest to fix in the software development lifecycle. Our customers actually inform us that they experience less defects reported from the field, higher quality code is delivered, and there is a very noticeable savings in labor. All right, so let's talk about coding standards. There are well-defined and industry-accepted coding standards like MISRA, AUTOSAR C++14, CERT, CWE, OWASP, and many others. Some of these standards, like MISRA, are developed by a collection of individuals from various companies that contribute their many years of experience in software development to define the best coding rules and guidelines. In fact, Parasoft is a contributing member of the MISRA C and C++ working group. Actually, MISRA is the de facto standard for C and C++ in developing safety and security related electronic systems or embedded control systems. You also have Carnegie Mellon University SEI CERT, secure coding standards for C, C++, and Java. And you also have coding standards like the Joint Strike Fighter Air Vehicle, or JSF-AV, from Lockheed Martin. You can, again, create your own standards. It's JSFD is actually a coding standard to help produce error-free code. Now, I've also listed MITRE's Common Weakness Enumeration, CWE. Technically speaking, CWE is not a coding standard. It's a list of software and hardware known weaknesses. The list includes common programming errors, design errors, and architecture errors, any of which may lead to exploitable vulnerabilities. However, many of the listed weaknesses can be identified through static code analysis, which Parasoft supports to help ensure compliance to CWE. Of course, in conjunction, users can also apply unit testing, integration testing, API testing, and other methods that Parasoft provides to help ensure security. CWE also puts out a list of the top 25 most dangerous software weaknesses. Actually, there's also the open source OWASP Foundation that produces freely available articles, provides methodologies, documentation tools, and technologies in the field of web application security. They also produce an API security top 10 list, which includes the most pressing security threats facing today's complex API ecosystem. Parasoft provides the most comprehensive coding standards coverage. We also provide a utility for users to create their own rules or blend or customize existing coding configurations. Okay, I'm now going to pass it over to Igor, and he's going to be talking about how generative AI helps with remediation of these violations. Again, very interesting and exciting information. So over to you, Igor.
Yeah, thanks, Ricardo. Appreciate it. So today's our focus will be on the usage of artificial intelligence in software testing. But we want to just note that AI itself as a software is changing over time. It started probably like state of the art with computer systems which were able to play chess games, right? And later on, the systems becomes more advanced and sophisticated to understand human speech, to understand human writings. The system were created to, like, for example, to book your trips, airline tickets. You can schedule your flight from Los Angeles to Boston using those systems without even talking to any like live person. And obviously with generative AI, with ChatGPT, which comes into the play, it's open horizon for new opportunities. And we don't even know how much of those new capabilities will be accepted and used on daily basis and becomes like normal routines. But at the same time, we obviously looking into capabilities of those systems, not as much as replace the humans, but rather to work with us, enhance our tools to allow us to do more sophisticated jobs and increase our productivities, taking away from us all those like mind-boring tasks and improve our performance this way, but at the same time not to take away those our own responsibilities. So human engagement is critical in these systems. And from testing perspective, Parasoft been using AI systems for years. Obviously, if you follow our webinars, our blogs, you would know that we are focused on, for example, using AI for creations of tests, for unit tests and functional tests. We are optimizing execution of those tests as well based on changes. We try to increase the performance and run the minimum number of tests just to get feedback on how the quality of your products after recent changes are. We try to address problems of instabilities of the test using self-healing technologies and different techniques. And generally, we try to reduce the noise associated with the problems and reduce the business risk doing such things. At the same time, focus our developers on relevant issues, on those which are probably exposed the most, and help them to fix those problems. Static analysis, it will be one of their example where we have many different AI techniques and machine learning capabilities built into our products, and to help developers to actually get the compliance with those standards which Ricardo mentioned before. Of course, the advantage of static analysis would be to detect majority of their problems even before you start execution of your code. Ideally, you want to run static analysis rules from the very first line of your code. And majority of the customers do such because they understand the value. But for those development organizations who turn on the rules, for example, being in the middle of development, or even worse, when they get into the end of the release cycles, and now they come to needs to certify those products against those standards, they might be overwhelmed with the problems of dealing with thousands, maybe 10,000 of different violations. And now they need to figure out, well, which of them they need to fix and how they're going to fix those problems. And here where we come with different technologies which we built over years, it's AI-based technology, which actually help the people and developers to do exactly that, doing triaging and prioritizations of the static analysis problems, focusing on those which the most critical ones. The first one, techniques we're using, is based on different classification techniques. We learning the developers' behavior, how they actually deal with the previous violations, which of them have been fixed, which of them have been suppressed, because some of them might be considered to be noise. And basically, executing these classifications, we can group those violations into clusters and predict when new violations come into the systems, whether the violations most probably need to be fixed because we find common properties together with what similar violations which were fixed by developers before, or maybe they will recommend them they need to be suppressed in the future because, again, we find similarity with the previous violations which user treated as the suppressed ones. In either way, we help the customers to triage the violations when they come to the systems and focus them on those which consider to be not noise but something that need to be fixed. Another techniques which we call hotspot detections, it's we analyze the entire space of all the violations which comes to the systems across all the project sources, and we perform root cause analysis and trying to find the groups of the violations which can be associated, for example, with single line of code which need to be changed. And such, through this one modification, one fix, the customers can address entire group of violations, could be tens, could be even 100 ones. So detecting those spots allows us to basically assign the entire group of those violations to one single developer, and the developer can focus on fixing that particular line of the code, rather than instead of entire group of development teams will be just trying to, each of them doing their own research and trying to fix maybe the same problems which common for multiple of those violations. So it's optimizations of work distributed across development teams. We didn't stop there either. We are analyzing the history of how those violations have been fixed and by whom. Basically, for each developer, we created profiles associated with type of violation they've been working in the past and they've been fixing. It's analogy of, you can think about in Netflix. When you're watching a movie, it's a system kind of doing analysis and predict what kind of movie you might want to look in the future. The same thing is applicable here. We call this matrix factorization techniques. It's basically project on the new violations which come into the system, who from the development teams will be most suitable based on the previous experience to fix those violations. So again, we try to optimize the performance of the development teams, assigning them violations where they have the most skills to be able to fix those. And if you combine all those different techniques together, the entire workflow can look like this. Like, assuming that we have 5,000 violations come into the product, and the challenge now for development teams, like, okay, how are we going to work on those violations? Whom we need to assign them? Which of the violations need to be prioritized, and which of them need to be suppressed? And the first things what we will do, we will apply this classifications technique to basically highlight the most critical violations which need to be resolved, and suggest which might need to be suppressed based, again, on the previous history of how the development teams handled the previous violations. After that, we will detect those hotspots with ability to kind of assign them to development teams based on those skills which we learned from their previous executions. Overall, when we combine all those different AI-based techniques, we help the development teams to optimize their performance when they actually approaching the problem of fixing those violations to be in compliance with different safety critical standards. And of course, this is just about triaging and prioritizations, but when generative AI comes into the picture, you can consider now like how we can help to use this, help developers using the technology to actually help them to fix those problems. And that's where Nathan, he can actually tell us more about those new capabilities.
Great, thanks, Igor. So yeah, Igor's been describing some of the technology that we've been building into our products for the past few years. Now, ChatGPT came out earlier this year, and it spurred a wave of research and innovation, people trying to figure out what can we do with it. So then what I'm going to share with you next is some of the research that we've been doing around how we think generative AI can help us in the space of addressing static analysis violations and in general software compliance. I probably don't need to go through this too much. Most of us know how ChatGPT works, but just quickly, it's a conversational AI model that understands and generates human-like responses to text-based conversations. It's based on the GPT architecture, which stands for Generative Pre-trained Transformer. It's been trained on huge amounts of text data, and people have found a variety of applications. We're finding more and more every day what it can be used for. And so we've been doing research on how can we apply this kind of technology to automated software testing. As Igor and Ricardo have described, we already have state-of-the-art static analysis technology that can find real security and quality violations. Our goal is to have minimal false positives and help users find real problems. But when we're addressing static analysis violations, as soon as we decide on which violations to fix, right, using, say, the technology that Igor described, we still have the issue of, if I'm looking at a violation, I first need to decide, is this something I need to fix? And then if I decide that I need to fix it, how do I fix it? And so we've been doing some research around both the areas of helping developers triage the violation, understanding what it is, why it was reported, is it a real issue or not? And then also helping them understand, well, if it is a real issue, how could I fix it? And fixing static analysis violations is like the holy grail of, static analysis, right? If we could have a technology that automatically fixes our violations, that's the holy grail. So we're trying to figure out what we can do in that area. So to describe this, I'm going to show you some research that we did using ChatGPT that shows how we could use this technology in both of these ways. So here's an example of, we took a rule. The rule basically says, make sure that all exceptions that get thrown are either logged with a standard logger or they get rethrown. Basically, it's a security issue. You don't want to hide exceptions. So our tools reported this violation on a piece of code. You see the code on the right. And on the left, we have the documentation for this rule. So all of our tools for each of our static analysis rules. We have comprehensive documentation that describes what the rule is, why it's important, example code that violates the rule, as well as fixed code. I show an example of that code being fixed and what that looks like, and so on. And so we thought, well, what would happen if we fed this information into ChatGPT? So we gave it the rule documentation and we gave it the code. And so we created this is just a prompt we use for research. We basically said, okay, given following source code and the following rule, please give us an explanation on whether this code violates the rule. Give us your reasoning why, and any other comments that you might have as far as like maybe some cases where the rule is not applicable or doesn't apply. And surprisingly or not surprisingly, it came back with some very interesting data. So it gave us a good explanation of what the rule does based on synthesizing our documentation. It came back with a set of reasons why this specific code violated the rule and explicitly decided that it does. And then the comments at the bottom were very interesting because it gave an actual legitimate reason that you might not need to follow the rule in this particular case. You know how all static analysis works. There are always exceptions to the rules, and this happened to identify a good case. So from the perspective of triaging, this information would be very helpful to a developer trying to understand, when I'm looking at this code, is this a real violation of the rule? And it helps them think through the different aspects of the problem and whether they should try to fix it or not. So then the next thing that we researched is, can it help us fix violations? And for this experiment, I'm going to switch to a more complicated example. This is a result from one of our flow analysis rules that basically analyzes the traces of execution through the program and will identify issues that it can find through analyzing the traces. In this particular case, we had a rule that is checking for strings that are not null terminated, which can cause all kinds of problems. And in this particular case, it found a violation in some code, and the flow traces through 4 different files. So there's a start point, a starting file where the variable is originally initialized, it passes through some logic, and at a certain point, it identifies that the string would not be null terminated. So we said, well, what would happen if we fed appropriate information to ChatGPT and asked it if it could help us fix this violation? So we gave it the source code of each of the 4 files. We fed it our rule documentation. So the same thing I already described with the description of the rule, the examples of the violation, how you would fix it. And then we provided the specifics of the violation that got reported. So the specific error, where we were using a string that's not null terminated, where that happens, so which file that happens in, and basically the beginning of the trace. We told it started in this file, and then obviously the non-null terminated string was used in this other file. And we asked it to fix the bug. Too far. And again, we found some very interesting and compelling results. In this particular case, it identified multiple places that we needed to fix in the code. So identified the place where the variable was initialized, saying that at that point, the developer needs to make sure that it's null terminated when it's first initialized, as well as code further down in the trace where when data gets copied into the string, the developer needs to make sure it's null terminated at that point as well. So all of this to say, this is we got some very compelling results on how it could help us in fixing, both triaging and fixing static analysis violations. And so I'm happy to report we are actually actively putting this into our products as we speak. We're not interacting with ChatGPT directly. We're going to be going to the OpenAI APIs, but basically doing the same thing. And just stay tuned, because the upcoming releases of our products are going to be having this technology built in. So to summarize, we've been talking, we found that there's a lot of different ways that we can bring AI to help in the areas of software compliance, from more traditional AI techniques to things that we can now do with generative AI. When we're looking at this, there's both great opportunities as well as concerns that people have. So I'll just briefly touch on some of these. On the opportunity side, we see that there's the opportunity for increased productivity. So helping users triage the violations, understand which ones they should fix, then helping them more quickly understand them and actually fix them. Different studies have shown that using some of these AI tools can even bring 30 to 50% productivity improvements. So there's the potential for great improvements there. With some of these generative AI tools, they synthesize a lot of information in one place. So it's a central place to get information and use it. The most, I guess, what would you say, notorious or the most well-known models right now, the ones that seem to operate the best at the moment are commercial models. But we're closely watching the open source space, and we're finding that open source models are quickly catching up to the commercial models, especially if you look at open source models that are tuned to solve specific tasks, right? The models like the OpenAI model is a very general model. It ends up being able to do a lot of different things. But our expectation is, in not very much time, some of these open source models that are tuned for very specific tasks will catch up to and maybe even surpass some of these more general commercial models. So we're watching that very closely. And in general, we've seen that some of these technologies, they have great potential for aiding with software development and testing tasks. Now, there are obvious concerns that people are bringing up. So especially with generative AI tools, the well-known word today is hallucination. So they make up things sometimes. That data is not always correct. So when using these tools, people have to be very careful not to just assume that is automatically correct. They can use it as a tool. They can use it as input to what they're doing, but don't want to just accept it without critically looking at it, because there are incorrect things that are injected by these generative AI models. There's concerns around regulation, how much, what kind of regulation do we need? Things related to what data is it trained on? The output of the models, does it have biases and so on? So there's, different countries are working on regulation right now. A key concern when sharing data with these models is, does the data get used and stored for training the models or updating the models? So that's a key concern. And we're seeing a lot of attention being placed on that. OpenAI is saying that, they don't use your data to train their models. There's now an Azure version of OpenAI where people can deploy the models in their own personal sandbox. So this is quickly evolving. These companies are understanding the need for data security and privacy. There's the concerns. People say, well, will AI take my job? At this point, it does not look like it. In general, we're finding that these models tend to be very good at things that it was trained on. So if there's common patterns, like maybe an e-commerce website, there might be some very basic things that it can do without much human intervention. For very complex, unique kinds of tasks, it's just an aid at this point. It's not going to be taking our jobs right now. And lastly, there's concerns around, the content that it generates. We don't know what the model was trained on. Is it going to generate content that might violate someone else's IP? So, there's a lot of different concerns. But in the end, we look at this as a whole. It looks like AI in all of its different forms is here to stay. And the industry and the regulations and everything's going to keep evolving. And so we need to figure out how we can use this technology in the most effective ways to enable us to do a better job more efficiently. Most likely, the people who succeed are going to be the ones who know how to use these tools more effectively. So with that, I'm going to pass it back to Ricardo.
Mm-hmm. Well, technology is changing very fast, and generative AI is an amazing wonder, and it's actually paving the way. So be sure to stay on top of it. Thank you, Nathan. Thank you, Igor. That was very informative. Now, before we jump into the Q&A, we have provided some great content. You can click on the pay-per-click icon on the vertical bar that you see on the right-hand side. And so be sure to go through some of that. Also on the slide, there are a couple of QR codes. The one on the left is to a white paper and guide for AI and software testing, so recommended reading. The other one, on the right-hand side, the other QR code, you can use to reach out to the Parasoft team after the webinar, and you can ask questions. You can also just email us directly at info@parasoft.com. All right, just some of you already submitted some questions, but to submit your questions, you can click on the question mark on the vertical toolbar that you see there as well. In fact, this is interesting. One of the questions here is, how will this affect my job? What's the risk of being replaced?
Yeah, so I briefly mentioned that. At this point, we don't see this as being able to take your job. From all the experiments that we've done, it's a useful tool, but for very complex, unique tasks, we still need human input. As I mentioned, I think using these tools though will help people to be more productive, and will give them, if you will, an edge up against some of their peers who might not be using it. So I would say figure out how to use the technology, but I don't think we need to be worried about losing our jobs right now.
Yeah, kind of touch on this topic as well. I would consider them more like assistant technology. Some people call it co-pilot. So those tools which are enhanced with AI can help us to become more productive, do our job better. But in terms of completely replacing, I don't think that's the current state where we are.
Mm-hmm. Yep. Okay. So another question here: can I really trust the results provided by generative AI? How do I determine its validity?
Yeah, I think I touched on that a little bit as well. So in general, you cannot trust it. We've had our teams internally, using it, and basically what they were telling us was it's very useful. It speeds up their work, but they do see mistakes in it. The risk is that you because the output seems so intelligent, it can be easy to start and because it is often correct, it can be easy to start assuming it's correct. But I think we really need to guard against that, and look at all code with a critical eye, just as we would any code that was written by any person, right? And at Parasoft, we're in the business of helping people validate their code. So all of the traditional code techniques that you would use for human written code, such as static analysis, unit testing, code review, all those sort of things, those apply just as much to code that you might get from any of these generative AI tools. It's just as important, if not more important, due to the fact that we have the tendency to inherently trust it when we shouldn't.
Mm-hmm. Okay, great. Thank you. We also have another question. What is your plan of feeding ChatGPT with your own data or domain-specific data?
So this is area for active research right now. We are actually looking into different projects, how we can build our own domain-specific models. We do believe that that's how we can enhance the quality and increase the trust level and differentiate ourselves from competitors. So our dedicated team just looking into that space right now. We have a lot of data which we're getting from performance static analysis, running those test executions. If we aggregate all this data, I'm pretty sure we can get very interesting results. So that's definitely our future.
Okay. So we have another question. In your experience, do you have an estimate of the productivity improvements you would achieve with the use of AI?
Well, it depends on which area where it's going to be applied, right? If, for example, if you're talking about unit test creations, our customers making pretty much consistent statement that it gives their improvements like 50%. And it's across multiple different customers, right? If you're talking about ability to automatically fix the violations, difficult to say right now. It depends on the complexity of the sources, complexity of the problems which you'll try to solve. But definitely it will be faster than developers doing like Googling and trying to find those results somewhere else. The whole value of the system that it will actually deliver that solutions and suggest it to you right just out of the box, right in your eyes, right? I mean, you still need to, as Nathan pointed out, to validate, verify the correctness of the solutions, but it will eliminate a lot of like overhead associated with like trying to search for those problems somewhere.
All right, very good. And we have one other question. How do open source models compare to commercial models?
So from our internal research team, right now they're not, open source models are generally not as good as the commercial models, but it seems like every few days they're getting closer and closer. Some project comes out with results that are even closer and even closer. I think I saw one yesterday that passed an earlier version of GPT-4. It's not quite up to the latest version, but it's getting close for a very specific task. So the open source models are clearly getting better. As I mentioned when I was speaking earlier, I think eventually open source models, especially ones that are trained for specific tasks, will likely pass commercial models that are more general, is what it seems like. But we're watching the space closely. Things are happening all the time. So,
Okay. Well, we don't have any more questions, and so I want to thank you, Igor and Nathan. That was very informative, and I'll probably rewatch this again. Actually, one last question came in real quick. How far are we from being able to validate these tools to be used in regular environments like medical, etc.?
Well, technology changed so fast, and we'll see probably new tools coming to the market like every single week. You'll have more news, and I think it's a matter of time for specific for validation by the customer themselves based on the industry, right? Of course, if you go to more like safety critical industries, the requirements and expectations will be much stricter, and that's where the regulations that actually teams and working on different regulations to be sure that it's normalized and it's safe for usage. It's difficult to predict when the things will take place and when it will happen, but I would predict that by the end of this year there will be a lot of development in these areas, and we might see some changes already coming right away.
Yep, I agree. All right, folks. Well, we have no more questions. Thank you again. Remember that this is a series of webinars on AI, so please visit our website. We have on-demand webinars there. And if you have any last words, Igor or Nathan, it's open to you.
No, I think we're good. Thank you all for joining.
Yeah, thanks everyone.
Okay, bye everybody. Thank you.